have another example here. A gear case for an electric crane has a mass of 150 kg and it has to be hauled up a slope of 35 degrees. A force of 1150 Newton applied at an angle of 15 degrees to the slope is required to move the gear case up the slope at a uniform speed. And they say calculate the coefficient of friction. Now let me just put the body on a plane so that you can see what the question is asking about. And I replace the gear case as this, all right? The plane is inclined at 35 degrees. And now they said a horizontal force, a force inclined at 15 degrees, all right? So if I draw this horizontal, the force here is inclined at 15 degrees, all right? Okay? And then the force is 50 Newton, all right? This is what the question is saying, that we incline force at 15 degrees, the force is 1150, and then the incline is 35 degrees. Now I can resolve this into the force diagram. Let's see. If I draw the incline here, all right, let's draw a bigger diagram. All right, this is the gear case now. I place it here. All right, okay. Then gradually, I will put in. All right, this is the normal reaction, R sub N. Are we there? This is the weight acting downwards. All right. Now, if I call the weight W, are we there? Mark you, the angle is 35 degrees. Are we there? Now, it's trying to pull the gear case upwards. The force will be trying to pull the gear case upwards. All right? Now, if I resolve this force, 1150 Newton, I'll have two forces, one in the vertical direction and the other in the horizontal direction. Now, if I put this force, the vertical force, right, and then the vertical force, if I resolve it, I will have the horizontal force. This will be the horizontal force. That will be 1150 cos. Cos what? 15 degrees. Are we there? Then we'll have the vertical force, 1150 sine 15 degrees. Normally, this force is trying to pull the gear case upwards, so the force of friction will act towards the left, which will be mu Rn. All right? Now, mark you, the weight of the gear case is acting downwards. If I resolve the component of the weight into two component direction, this will be W sine theta, right? Mark you, this angle is theta. Are we there? Now, the vertical component of the weight will be W cos theta. By far, these are the forces acting on this body. Now, let's see. Resolving the forces perpendicular direction, resolving the systems of force, system of forces, in the what? In the, let's go in the perpendicular direction. Perpendicular. Perpendicularly. Let's see. Perpendicular direction. We have what? Rn plus what? 1150 sine 15 degrees. These are the two forces acting upwards, right? It will be balanced by what? W cos theta. Let's call this equation number 1. Are we there? Then resolving the system of forces parallel or horizontal. Resolving the system of forces in a horizontal direction, horizontally. What do we have? Now let's say horizontal. We have mu rn plus w sine theta will be opposed by what? Equals to 1150 cos what? Cos 15 degrees. All right? These are resolutions. Now supposing we want to make Rn the subject of equation 1. So we'll say from 1 we have Rn, that's normal reaction, is equal to W cos what? Cos theta minus 1150 sine what? Sine 15 degrees. Let's call this one, this was equation 1, this was equation 2. Equation 2, alright? Now let's call this equation 3. Alright? So from one, what we merely do is to carry this force to this. So we have Rn is equal to W cos theta minus, because we are carrying this from the left hand side to the right, minus 115 sine 15 degrees. That gives us equation number 3. Let's sub 3 in what? In 2. So what will we be having? We'll be having mu. What is our Rn? Rn is what? W cos theta minus 1150 sine 15 degrees. Are we there? Okay? Are we there? Equals to what? Equals to 1150 cos 15 degrees. Are we there? Are we there? So let's see, what do we do? We have our mu. Let's make mu the subject of this formula. So we'll be having mu equals to 1150 cos 15 degrees all over W cos theta minus 1150, right? Sine what? Sine 15 degrees. Okay? Let's input our weight. What is our weight? The mass of this was 150 kilograms. So I can say our mu equals to 1150 cos 15 degrees all over the weight 150 times 10. The weight is mass times acceleration due to gravity. Times 10 cos what? Cos what was our angle of the plane? 35 degrees. Cos 35 minus 1150 sine what? Sine 15 degrees. Are we there? When we evaluate this, we get our mu. Let's see, please. We get our mu equals to, when we say 1150 cos 15 will give us 250. Are we there? And then when we evaluate 150 times 10 times cos 35 minus 1150 sine 15 degrees, it will give us 931. And once we evaluate that, 250 divided by 931, it will give us 0.27 as our coefficient of friction. So I have explained in our previous classes that coefficient of friction has no unit. It is a ratio. So the coefficient of friction, it says ask us calculate the coefficient of friction. Therefore, From our workings, the coefficient of friction is 0.27.